All right, here's the last problem for 915. A cool problem because it brings back the tetrahedrons that we built in chapter 7. So if you remember that, this is kind of why we built it, to talk about it later on in chapter 9 here. So what they're saying in the problem, and it's pretty important here in 955, is that we constructed the tetrahedron like the one at the right, and now we are going to assume that the dimensions of the shaded tetrahedron, so that top part, all the dimensions are half of the dimensions of the enlarged tetrahedrons. All right, so that tells me that if that's half the dimensions, let me grab my pen here. If that's half the dimensions, or the dimensions are halved, to go from big to small, is a linear scale factor of 1/2. To go from big to small, we have a linear scale factor of 1/2. Everything gets cut in half. Okay? That's important as we get into part A here. And in all these problems, you can kind of see that, like, I've always tried to pick out a linear scale factor, because if I can say I have a linear scale factor, either big to small or small to big, I can then find an area scale factor if I need one, or a volume scale factor. Okay? All right, so in part A, it's saying the volume of the large tetrahedron is 138 inches cubed. Find the volume of the small tetrahedron. All right, well, that's not too bad because I have my scale factors. So part A, my volume of my big, the volume of my big one is 138. Okay? I'm going to multiply that by my linear scale factor cubed so I can change volumes. So I can use my volume scale factor here. All right? And again, I'm using that 1/2 because I'm going from a big volume, from a large volume, to a small volume. So I want to use my linear scale factor that takes me from big to small, and I want to cube that linear scale factor because I really am using a volume scale factor. All right, when I do this, 138, and then 1/2 cubed is the same thing as 1 cubed divided by 2 cubed, and 1 cubed is 1, and 2 cubed is 8. So what I'm doing is I'm multiplying here 138 times 1/8, and 138 times 1/8 is going to give me an answer of 17.25. And that's the volume of my small. That's the volume of my small tetrahedron. Okay, so 17.25 inches cubed is the volume of the small. And that's part A. Okay. Now part B is a little different. There's different ways we go about it. But what we have here is if the small shaded tetrahedron, so the small one again, has an edge length of 16 centimeters, find the total surface area for each tetrahedron. All right, and now I think this one's worded kind of funny, so what I'm going to do here is I'm going to find the surface area of just one of the tetrahedrons, and then I'm going to find the surface area of the whole shape. All right, just because I honestly, when I read this question, don't know exactly what they're looking for. They say total surface area for each. Does that mean they want to find just one because it's each, or do they want to find all of them? So I'm just going to do it both. All right, so what I'm going to do here is I'm going to actually have to draw this one out a little bit. And so what it's saying is that these tetrahedrons are made up of equilateral triangles. Okay, so we're going to pretend that I can actually draw an equilateral triangle, and it's saying that it has an edge length of 16. All right, now these tetrahedrons are really made up of a bunch of these, that equilateral triangle, just a bunch of them. All right, we have, 3 equilateral triangles around, and then 1 equilateral triangle as the base. And so we are really making these tetrahedrons, or that prism, that 3-dimensional shape, is really made up of 4 equilateral triangles as its faces. All right, and so I just need to find one quick. I kind of got sidetracked there. I got to find one before I can find all of them. All right, and so I have a base, and I need to find a height. All right, I need to find that height there because base times 1/2 base times height is how I find the area of a triangle. All right, and so this is an equilateral triangle. And so I know that equilateral triangles, all their angles are 60 degrees. All the angles are 60 degrees in an equilateral triangle. That means if I use this apothem to try to find the height, that I'm cutting that in half, and I just have a 30-degree angle right there. All right, and again, I'm doing that because I really want to use this right triangle here in this apothem to figure out the height of that triangle. And so if I redraw what I have here, after I made the apothem and everything, I actually have a right triangle with that angle right here is 30, and the apothem cut my length, so this down here is 8. Now you could use trigonometry and use the tangent of 30 equals 8 over x. You could figure out x, or because this is a 30, 60, 90 triangle, you could use 30, 60, 90 rules. Well, across from the 30 is the short side. That means the hypotenuse here, the long side would be 16, because the long side or across from the 90 is always 2 times the short side. And your x side here is really 8 times the square root of 3. All right, so then I actually have my height there, even though it's 8 square root of 3, that's the height of my triangle. And so if I want to find the area of this triangle right here, I now can. I can say it is 1/2 times 16, because that's the base, times 8 square root of 3, because that's my height. When I work this out right here, 1/2 times 16 is 8. 8 square root of 3 stays 8 square root of 3. And then when I multiply this, I do 8 times 8, and I let the square root of 3 hang on there. And so 8 times 8 is 64. And the square root of 3 kind of just hangs on there. And that's the area of one face. That's the area of just one face of these three-dimensional shapes, this small tetrahedron. All right? Well, there is, like I said, 4 faces that make that up. There are 4 faces that make up that shape. And so I'm going to take my answer here, and I'm going to multiply it by 4 for the 4 faces that it's made up of. Okay? And then when I do this, that's going to give me my total surface area here. Okay? And so 64 times 4 gives me 256 square root of 3 still. And that is the surface area. That's the surface area of just one small tetrahedron. And like I said, I'm kind of confused by this problem, and so I'm going to use that. I want to say that's one of my answers, 256 square root of 3, surface area of just one. But I also want to figure out the surface area of this whole shape. Now, this surface area of this whole shape, I'm just going to say, well, I know the surface area of this one right here. Well, the whole shape is made up of 4. 1, 2, 3, 4. And so I'm going to take my shape, I'm going to take my 256 square root of 3, my answer for just one, and I'm going to multiply that by 4 because there's 4 of those shapes, and I'm going to have the surface area of the entire large tetrahedron. And so 256 times 4 gives me 1,024, still tagging on the square root of 3 here, and that is the surface area for the whole shape. All right. And that's, like I said, I wanted to use both of them because I didn't really know what the question was asking for. So surface area for just the one small tetrahedron, and then surface area for the whole big tetrahedron. Okay. This is a really good problem, just in the sense of finding area of a triangle, finding surface area, and then multiplying that surface area to figure out the big surface area. All right. Now the last problem is actually kind of short. It's saying that in class, we constructed this tetrahedron using 4 smaller congruent tetrahedrons. However, the result left a gap in the center, as shown in the diagram of the right. They're saying if the volume of each small tetrahedron is 50 inches cubed, what is the volume of the gap? Well, there's a really quick way to do this problem in just saying, like, when we work hands-on, which we would have been in class, you would realize that that gap right there could hold 4 small tetrahedrons. Believe it or not, that gap in the middle can hold 4 small tetrahedrons. So what I can do for this problem in C, and And I'm kind of just going through it quickly because, again, it's way better when you have the actual hands-on. You can see this. But you have this problem in C. You have that gap is made up of 4 smaller tetrahedrons. And in that problem, it says each small tetrahedron has a volume of 50 inches cubed. And so that volume in the middle is 4 times 50, which means it is 200 inches cubed for that volume in the middle. That's really short and sweet. I again would go further into it if we were in class and working hands-on with it, but I just know from working on this before that you can fit 4 small tetrahedrons in there, and so I'm just doing 4 times the volume to say that that's 200 inches cubed in the middle there. All right, that's the last problem. Take a look at the math notes. The math notes do a really nice job today breaking down linear scale factor, area scale factor, and volume scale factor. So make sure you take a look at that and give the homework problem a try.